300 miles off the coast of Oregon, deep beneath the surface of the Pacific, the ground is moving. Not just shaking, it is physically rising. Instruments anchored to the sea floor confirm that a massive section of the ocean crust has lifted nearly 2.4 meters in just a few years. Thousands of earthquakes are currently rattling this specific point on the map. The pressure is building. The signals are clear. The most active underwater volcano in the Northeast Pacific is inflating like a balloon, and scientists believe it is about to burst. But what happens when a volcano erupts under a mile of ocean water? Today, we are diving down to the Axial Seamount to understand the engine driving this activity and to answer the critical question: what does this geological giant mean for the West Coast? This is the Axial Seamount. It sits on the Juan de Fuca Ridge, a volatile boundary where the Earth's crust is constantly being reshaped. And right now, we are witnessing a textbook example of volcanic inflation. Think of the volcano as a pressure vessel. Since its last major event in 2015, magma from the mantle has been steadily filling the reservoir beneath the caldera. As the chamber swells, it pushes the overlying rock upwards. That 2.4-meter rise isn't debris. It is the entire seafloor bulging under the strain. The rock can only stretch so far before it snaps. The swarms of tremors we are seeing now are the sound of the crust beginning to crack. It is a clear countdown. The geological data suggests the system is primed for its next release, likely around 2026. Whenever we talk about seismic activity in the Pacific Northwest, the immediate concern is the big one: the Cascadia subduction zone earthquake. However, it is vital to distinguish between these two systems. The Axial Seamount operates independently of the Cascadia fault. While Cascadia is a zone of collision and compression, Axial is a zone of separation. An eruption here relieves pressure locally. It does not trigger the continental fault line closer to shore. Furthermore, the depth of the ocean acts as a massive shield. At 1,400 meters down, the hydrostatic pressure is immense, over 2,000 pounds per square inch. This pressure suppresses the explosive expansion of gas. Instead of a violent blast that could generate a tsunami, we get an effusive eruption, a relatively gentle outpouring of lava that stays on the bottom of the sea. The Axial Seamount is unique not because of the danger it poses, but because of the access it provides. It is the only volcano on Earth hardwired to the internet, with a permanent fiber optic observatory. We aren't just guessing what happens down there. We are watching the planet create new crust in real time. It is a reminder that the Earth beneath our feet is alive, dynamic, and constantly changing. And for now, from 300 miles away, we have the privilege of watching it safely.